Hey guys, it's your boy Raj. Now before I begin, I'd like to give a quick shout out to Mr. Happ for having us do this project. Thank you, Mr. Happ. Now let's get right into it. Today we'll be covering section 2.7, Derivatives and Rates of Change. Sounds interesting. So first, let's see, what is a rate of change? Now many of you know that the rate of change is also known as the slope. And basically it's one variable is changing proportionately to another variable. So that is the rate of change. Now if we can easily take the equation y equals 2x plus 1 and determine, okay, the slope is 2, and that means that the rate of change is 2. And we can graph it and we can see, oh, throughout this line, the slope is always 2. So we can see that the rate of change here is constant. But what happens if we cannot see that the rate of change is constant? What if we're given a parabola such as this, y equals x squared, and we're told to find the instantaneous rate of change at a certain point? And then you might ask, well, Mr. Rajit, how do you find the instantaneous rate of change? But that's about what I'm going to tell you. The derivative. Now the derivative is the instantaneous rate of change at any given point on the graph. So if we wanted to find the instantaneous rate of change of 1, 1 on this graph, oh, you bet we can. So let's get right into it. We can find the derivative and the equation of the tangent line to a point two different ways. Let's start out with method number 1. Let's say we're given this equation y equals x squared, and we are told to find the tangent line to the parabola y equals x squared at the point 1, 1. Now you might ask, well, is the slope just 1 squared? Haha, no, it's not. We need to determine it by finding the derivative and finding the actual slope at the instantaneous rate of change at the point 1, 1. Now let's get right into it. So basically with this definition number 1, it's m equals the limit as x approaches to a of f of x minus f of a over x minus a. So based on this, we can just plug some points in and bam, 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 we could get our answer. So let's do that right now. So we know that f of x equals x squared minus f of a. We plug in 1 to this equation, we get 1 over x minus a. A is 1 in this case. And boom, we can factor it out. X minus 1 times x plus 1 over x minus 1. Cancel these two out. X plus 1. But remember, it's the limit as x is approaching to a. So in this case, x is approaching 1. So what we're going to do here is we're going to plug in 1 plus 1 equals 2. And there we have it. We have our instantaneous rate of change. Yippee! But that's not all we've got to do. We have got to find the equation. Remember, we got to find the equation of the tangent line at the point 1, 1. Well, just like any other equation, we know that we need a slope. And we know that we need 2 points. So let's put it in point slope form. So y minus, we take this y value over here, 1, equals, this is where our slope comes into play. So 2 times x minus 1. And there you have it. That is the equation of the tangent line at that point 1, 1. Now that's great and all, but let's look at a second definition, or a second way to actually go about this problem. So now, the second definition we will use is limit as h is approaching 0 of f of a plus h minus f of a over h. We'll just use the same problem with the same points to show how we can still get the same solution. So what's going to happen, it's going to be f of 1 plus h minus f of 1 over h. So this will be 1 plus h squared minus 1 over h. And remember, the limit is h going to 0. So once we can factor this out and get h squared plus 2h plus 1 minus 1 over h. So we can see that these two ones will actually cancel out, and we're left with h squared plus 2h over h. Now we can cancel out these h's, and we're going to get h plus 2. But remember, it says h is going to 0. So we plug in 0 for this. 0 plus 2 equals 2. And boom, there you have it. We have the same exact slope, except in a different method. So we plug it back into the equation, y minus 1 equals 2 times x minus 1, and bam, bam, bam. There it is, just like that. Now let's go on to a different type of problem. Hey guys, let's get right back into this. So we'll be looking at velocity problems now. So let's just do one velocity problem and make sure we have this concept all down. So let's take a look. So suppose a ball is falling from the Empire State Building, and the equation is given f of t equals 2t squared plus 480, and because it's 480 feet off the ground. Now if we're asked to find the average velocity from t equals 5 to t equals 8, what do? We're going to find the rate of change, the average rate of change, and we are all experts at this by now. We've learned this throughout our school year. How do you find this? How do you find the slope? We plug in 8, plug in 5, we get 608 minus 530 over 8 minus 5, which would give us 78 over 3 meters per second. So guys, I'm expecting that we all know this by now. This is just average rate of change. This is one concept that we already have down. But now let's take a look at what happens if they ask us to find the instantaneous velocity at t equals 5. So, like I said before, let's just use our definition. Let's see what we come up with. So we can do f of 5 plus h minus f of 5 all over h. And remember, this is as the limit h is approaching to 0. So we always got to keep that in our heads. So if we plug that into the equation, we're going to get 2 times f plus 5h squared plus 480 minus 530 all over h. We can factor it out. We get 2h squared plus 10h plus 25 plus 480 minus 530 over h. We're going to end up getting 2h squared plus 20h plus 50 plus 480 minus 530 all over h. We cancel some stuff out. Bam, bam, bam. 2h plus 20. H is approaching 0, so we got 20, but don't forget the units, meters per second. So we can see that we now know solidly derivatives and rate of change. So let's just go over it one last time. The rate of change is the average rate of change. We take the y2 minus y1 over x2 minus x1. That's finding the average rate of change. And we remember the instantaneous rate of change, also known as the derivative. We've looked at that. We've looked at and seen two definitions of it, two ways to find it, how to find it, and find the equation of the tangent line. So guys, I'm feeling really confident right now. I feel like you guys have really got this. Just remember, you got to plug it in. You got to plug it into one of the equations, such as f of a plus h minus f of a all over h. Bada bada bam, bada bada bam. Just simplify it. Remember, it's always going to be limit as h is approaching to 0, and you're going to get your answer. And remember, if they ask to find the equation to the tangent line, all you know how to do that, and you just put it in point slope form. So, guys, hit me up, Instagram, Snapchat, at Raj13237. It's been a real pleasure working with you. Don't forget to like, share, comment, and subscribe. Do what you gotta do to try and get this video out there. Let's try and get 100 likes, 100 views. Let's try and get this. I'll keep pushing to make more videos. But guys, I really need your help. Once again, thanks so much. Peace.